Hello friends, myself R.D. Mazen presenting my video on application of partial differentiation revision part 1. Example number 1. If x is equal to e raised to theta plus I phi, y is equal to e raised to theta minus I phi, then find the Jacobian of the given transformation. Here x and y are functions of two independent variables, theta and phi. Therefore, that Jacobian is nothing but dou of xy divided by dou of theta phi, and therefore as per definition it is determinant of dou x by dou theta, dou x by dou phi, dou y by dou theta and dou y by dou phi, and therefore it is equals to differentiating this with respect to theta, keeping phi constant, is derivative is e raised to theta plus I phi. Chain rule, differentiation of theta plus I phi is 1. Then differentiating the same term with respect to phi, this time derivative is e raised to theta plus I phi into chain rule, differentiation of this term with respect to phi is I. Then differentiating y with respect to theta, it is e raised to theta minus I phi. Chain rule, differentiation of this term with respect to theta, keeping phi constant, is derivative is 1. Then differentiating same term with respect to phi, e raised to theta minus I phi into derivative of this term with respect to phi is minus I. And then evaluating the second order determinant, it is nothing but product of these two terms. Therefore, that one is minus I e raised to theta plus I phi into e raised to theta minus I phi. Addition of the power, we get 2 theta plus I phi minus I phi get cancelled. Then minus I times product of this, again addition of the power, theta plus theta, we get 2 theta plus I phi minus I phi get cancelled. And therefore, we get that value as minus 2i e raised to 2 theta. As a value of that Jacobian or the second example, if x is equal to root of vw, y is equal to root of uw and z is equal to root of uv, then find the Jacobian of the given transformation. And therefore, to obtain that Jacobian, as per definition, here it is dou of x, y, z divided by dou of u, v, w. X, y, z are functions of three independent variables, and therefore as per definition it is nothing but differentiation of x with respect to u, then with respect to v, and then differentiation of x with respect to w, then differentiating y with respect to u, differentiating y with respect to v, and differentiating y with respect to w, differentiating z with respect to u, differentiating z with respect to v, and differentiating z with respect to w. And if you evaluate this third order determinant, whatever the value is the value of that Jacobian. And then differentiating that three functions, differentiating x with respect to u, no term of u, therefore its derivative is 0. Then differentiating this square root, root of that, derivative of that root is 1 by 2 times root of vw. Chain rule, differentiation of this with respect to v is w. Differentiating it with respect to w, it is 1 upon 2 times root of vw. Chain rule, differentiation of this term with respect to w is v. Then differentiating y with respect to u, derivative is 1 by 2 times root of uw. Chain rule, differentiation of this term with respect to uw constant outside, derivative of u is 1, therefore w upon 2 root of uw. Differentiation of that term with respect to v, no term of v, therefore derivative 0. And differentiating the same term with respect to w, 1 by 2 times root of uw. And chain rule, differentiation of this term with respect to w, it is u. Then differentiating z with respect to u, it is 1 by 2 times root of uv. Chain rule, differentiation of this uv with respect to u is v. Then differentiating with respect to v, it is u upon 2 times root of uv, and derivative of that term with respect to w, no term of w, therefore its derivative is 0. And then evaluating this third order determinant as usual, therefore 0 into determinant of these 4 elements, 0 multiplied by any term we get 0. Then second with minus sign, minus w divided by 2 root of uw vw into, neglecting this row and this column, product 0 minus this product, it is uv 2 to the 4 root of u square vw, then plus v upon 2 times root of vw multiplied by, neglecting this row and this column, a product of this or determinant of this 4 element, this into this we get uw 2 to the 4 root of u square vw minus this product 0. Simplifying it, this one becomes uvw 2 to the 4 to the 8 root of u square v square and w square plus uvw once again divided by 4 to the 8 root of u square v square w square, u square v square w square, and therefore we get uvw 8 times divided by 8 times square root of u square v square w square, square root and square get cancelled, we get uvw plus once again same term uvw and divided by 8 times uvw. UVW get cancelled, therefore we get that value as 1 by 8 plus 1 by 8. It is addition 2 by 8 means 1 by 4. As answer or the value of that Jacobian. Therefore, here I have discussed two examples how we can evaluate that Jacobian. The next problem is for the property of Jacobian, J dash is equals to 1. Third example, if x is equal to e raised to v into secant u, function of u and v, and y is equal to e raised to v into tan u, then prove that j into j dash is equals to 1. And therefore, first we have to find out j means Jacobian of xy with respect to uv. This is nothing but determinant of dou x by dou u, dou x by dou v, dou y by dou u, and dou y by dou v. Differentiating x with respect to u, keeping v constant, therefore that e raised to v is constant term, and derivative of secant u is secant u into tan u. Then differentiate that x with respect to v. This time secant u we take as constant term, and derivative of e raised to v is e raised to v. Differentiating this y with respect to u, e raised to v constant term, derivative of tan is secant square u. And then differentiating this term with respect to v, tan u constant term, derivative of e raised to v is e raised to v. Then evaluating this second order determinant, product of this minus this product, therefore it becomes e raised to v into e raised to v as e raised to 2v secant u, tan into tan, that becomes tan square u, minus again e raised to v into e raised to v, we get e raised to 2v secant cube u, from this two term we take a common term as e raised to 2v as a common, and from this we can take secant u common. Remaining terms are tan square u minus secant square u. We know 1 plus tan square as secant square, and therefore tan square minus secant square is minus 1. We get that value as e raised to 2v into secant u into minus 1 as a value of g. We know this since 1 plus tan square u as secant square u. Therefore, tan square minus secant square as minus 1. And therefore, we get that value as minus e raised to 2v into secant u. Here half part is over. Then in second part we require to find out j dash, that is the reciprocal of this. We have j dash as dou of uv divided by dou of xy. Nothing but determinant of dou u by dou x, dou u by dou y, dou v by dou x, and dou v by dou y. And to obtain this all partial derivatives, we require to find out uv in terms of x and y. Therefore, squaring and subtracting x square, we get as e raised to 2v into secant square u, and minus y square as e raised to 2v tan square u. We get e raised to 2v common. Remaining terms are secant square u minus tan square u. We have the result 1 plus tan square is secant square, and therefore secant square minus tan square is 1, and therefore that value we get as e raised to 2v into 1 means it is e raised to 2v. Then transferring this term to other side, we get therefore v is equal to 1 by 2 log of x square minus y square. Differentiating this with respect to x, we get partial derivative as dou v by dou x, keeping y constant. Derivative of log is 1 upon x square minus y square. Chain rule, differentiation of this term with respect to x is 2x. Y square is constant term, is derivative 0. And therefore that value is 2 to get cancelled, we get x upon x square minus y square. Then dou v by dou y, this time keeping x constant, again 1 by 2, derivative of log is 1 upon x square minus y square. Chain rule, differentiation of this term with respect to y is minus 2y. 2 to get cancelled, we get minus y divided by x square minus y square. We get that term as x square minus y square. Therefore, these are the values of dou v by dou x and dou v by dou y. Then we try to find out, take a ratio of y by x, and therefore we get y by x is equal to y is e raised to v into tan u. Y is e raised to v into tan u, and x is e raised to v into secant u. E raised to v get cancelled. Tan sin by cos, sin u upon cos u, and this 1 by secant nothing but cos u. Cos u get cancelled. We get sin u as y by x, and therefore we get u is equal to sin inverse of y by x, a function of x and y. Then differentiate this with respect to x, keeping y constant, we get dou u by dou x as derivative of sin inverse is 1 upon root of 1 minus x square means y by x whole square. Chain rule, our differentiation of term y by x with respect to x is minus y upon x square. Cross multiplying it becomes x square minus y square upon x square. Square root of x square is x. Transferring it to numerator, we get x divided by root of x square minus y square, and into minus y by x square. When x gets cancelled, we get that value as minus y divided by root of x square minus y square. Then differentiating it with respect to y, we get again 1 upon root of 1 minus square of that y by x. Chain rule, differentiation of this y by x with respect to y, derivative is 1 by x. Cross multiplying, we get that term as x divided by root of x square minus y square into 1 by x. X's get cancelled, we get that value as 1 upon root of x square minus y square. Substituting all these 4 derivatives here in this step, we get substituting all that 4 derivatives, we get first one is minus y upon x into root of x square minus y square. Second derivative is 1 upon root of x square minus y square. Third one, x upon x square minus y square. And fourth derivative, dou v by dou y minus y upon x square minus y square. Evaluating this determinant, this product minus this product, therefore minus into minus it becomes plus, y into y we get y square, x into x square minus y square, here it is 1 by 2 and here 1, therefore it is 1 by 2 plus 1, adding the power, then minus x upon, again a product of this, it is x square minus y square, 1 by 2 plus 1, and therefore we get, we take the LCM as x into x square plus y square, 1 by 2 plus 1 we get as 3 by 2. Therefore, x into x cross multiplying we get y square minus x square divided by x into x square plus y square raised to 3 by 2. Transferring this to denominator, we get that value as 1 upon, taking minus sign common, we get x square minus y square. Here it is x square minus y square raised to 3 by 2. Cross multiplying we get y square minus x square upon this. Transferring this by taking minus sign common, we get x into x square minus y square, 3 by 2 minus 1. We get that value as minus 1 upon x multiplied by x square minus y square, 3 by 2 minus 1, 3 minus 2, 1 by 2 means the square root. And therefore, substituting the value, we get minus 1 upon x is e raised to v secant u, x is e raised to v secant u, and x square minus y square is e raised to 2v and its square root. We get that value as square root and square get cancelled, we get e raised to v into e raised to v minus 1 upon e raised to 2v into secant u as a value of j dash, and then take a product of j into j dash, we get. Substituting the value of j and j dash, the value of j is minus e raised to 2v into secant u, and just I have obtained the value of j dash as minus 1 upon e raised to 2v into secant u. Get cancelled, minus minus it become plus 1. Therefore, we get j dash is equals to 1. Result is proved. Therefore, in this in the first part of this video, I have discussed two important points: how we can obtain the Jacobian of the given transformation, and the second, the property of that Jacobian, j dash is equals to 1. In second part, I will discuss some problems of how we can find maxima and minima of function of two independent variables. If you like my video, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you. Thanks for watching.